Good morning. This is a continuation of section 2.5 homework. So I am starting at problem number 35. We've been given a function g of x equals x to the fourth minus 4x cubed. It's a long one, plus 8x squared minus 16x plus 16. And we need to find, the directions say, find all of the zeros of the function. So what I've done, let's see, just graph this function, plugged it into Desmos, and I can see that I have an inflection point here at 2, 0, and we know that when we have an inflection point, that means that we have a multiplicity of 2. So I'm going to go ahead and divide out a 2 using synthetic division. And I'm checking, of course, checking my function to make sure I don't need to have any placeholders. I've got descending order of the variable and everything seems to have a coefficient. So I'm going to follow my synthetic division process. 1 times 2 is 2 plus negative 4. Negative 4, that's 4. It's 8, negative 16, and 0. So I got a 0 when I divided, so that means that 2 is a factor, or is a 0, and so we said it had a multiplicity of 2, so I'm going to go ahead and divide it in again. That way I can get my function down to where it's an x squared. So 1 times 2 is 2. I've got a 0, and a 0, and a 4, and an 8. Okay, so my 2 went in twice evenly. That means I was right about there being a multiplicity of 2. And so that brings me to an x squared, and then I have no b term plus 4 equals 0. So this is one of those functions that I can, since there's no b term, I don't have to use any special factoring techniques. I can just subtract 4 on both sides, and x squared is negative 4. So I'm going to square root both sides, and I get x equals plus or minus 2i. So I verified the results graphically, which means there's no other place that it crosses the x-axis, and I want to write the polynomial as a product of factors. So we're going to have x minus 2 squared, x plus 2i, x minus 2i. That's way over at the edge of the page, so let me slide this over. So this here is my solution for number 35. Next problem, number 39. Let's see what we've got. We want to, again, we're given a polynomial, so let me write that down. F of x equals, let me adjust the camera here. Alright, f of x equals 2x cubed minus 3x squared plus 8x minus 12. And use my factorization to determine the x-intercepts. So I think I feel like they're wanting us to use the zeros to find the x-intercepts. So they're wanting us to find the zeros first. So I could list all of my p's and q's, and I could have a list of potential zeros. There's a lot of them though. 1, 2, 3, 4, 6, and 12. And then at least for q's it's just 1 and 2. So I have 1, 2, 3, 4, 5, 6, 12 potential numbers that I could plug in that are zeros of this thing. So just to save time on here, I'm going to go ahead and plug the function in and take a look at the graph. Let's see, I can just clear that. Okay, 2x to the third minus 3x squared plus 8x minus 12. Oops, I don't need an equals. Alright, so here's my function. Can you guys see that? Let's zoom out and see if there's any other places where... So that thing is a cubic, so we found the one spot that it's crossing, and it is crossing... Oh, I see. So it's crossing, it looks like at 1.5. So that's going to be our 3/2. So maybe that's why they put it that way. So let me go ahead and do a synthetic division. It's good for you guys to see the fraction ones worked out too, because you might have to do this. There's nothing that says we can't work with fractions. So I'll bring down my 2. 2 times 3/2 is 3. Then there's a 0. 0 times anything is 0. 8. 8 times 3/2 or 8 times 1.5 is 12. So now we get a 2x squared plus 8. And we can factor out a 2, and it's just like the last problem where we have two other factors here that it's going to end up being the square root of -4. So we get x equals plus or minus 2i. So our three factors, and I'm going to write it out as a product of factors, x minus 3/2, x plus 2i, x minus 2i. Alright, so number 43 is next, and that one carries the same set of instructions. So 43, we have f of x equals x to the 4th plus 25x squared plus 144. And so if we graph that, we're going to get x to the 4th plus 25x squared plus 144. And I'm zoomed way in there, so let me zoom out and see, is our graph visible? Oh, looks like there it is. Alright, so I've got a super skinny okay, so you can see that our y-intercept is at 0, 144. And our graph never ever touches the x-axis. So, what to do? So this one, it just happens to follow that pattern of I've got an x to the 4th, an x squared, and a 144. So I'm going to use a technique where I say, I'm going to use some substitution. Y equals... Okay, no, that's confusing because it's y. I'm going to say a equals x squared. So everywhere where I have an x squared, I'm going to substitute an a. So I'm going to call this a squared plus 25a plus 144. And I'm going to use the either a factoring technique, which I know it won't factor because it doesn't cross the x-axis, or I'm going to use the quadratic formula. So I'm going to say a is 1, b is 25, and c is 144, and I'm going to do my quadratic formula, which I'll write it out here, b squared minus 4ac all over 2a, so negative 25 plus or minus 25 squared minus 4 times 1 times 144, all over 2. So now let me work out the math. 25 squared, alright, let's see, calculator. So let's do 25 squared minus 4 times 144. I don't think that's right. 25 squared, 625, minus 4 times 144, close parentheses, equals 49. Thank you. I don't know where that other number came from. So negative 25 plus or minus square root of 49 over 2 negative 25 plus or minus 7 over 2 b squared minus 4 times 1 times 144. Okay, so it's weird that I'm getting just a negative number here. Like maybe I didn't look in the right place on my graph or something. So let me work this out. Negative 25 plus 7 is negative 18 over 2, so that's negative 9. Negative 25 minus 7 is negative 32 over 2, so that's negative 16. Oh my gosh, so it does factor. So hold on, let me look at... So on my graph I was looking really... No. Oh, okay. Alright, so what we've got here, this thing would factor like this. So x to the 4th plus 16 and x to the 4th plus 9, which is going to give us more imaginary roots. Or no, x squared. Okay, so that way we have our x's are plus or minus 4i and plus or minus 3i. Okay, that makes sense. So we still end up with these binomials that have a plus in the middle. So we know those end up with imaginary roots. So what we've got here is a function with 4 imaginary roots: x plus 4i, x minus 4i, x plus 3i, x minus 3i. And so we're done. Alright, number 45. 45 is, let's see, so now I need to find a polynomial with the given 0. So here's 2i and negative I. So we've already practiced some of these in class. So we are going to write out our polynomial x minus 2, x plus I, and x minus I. And remember, when you're working these out, it's always simpler to go ahead and FOIL your imaginaries first. So let's do x squared plus ix minus ix cancels, and then minus I squared, which would be plus 1. And so now I can FOIL that out. X cubed plus x minus 2x squared minus 2. So if I just rewrote that in standard form, I'll be good to go. Alright, and number 49, this is probably one of those messier ones. Yep. We've got some zeros here. 0, negative 5, 1 plus radical 2i. And then the thing you guys are supposed to fill in is you're supposed to realize you cannot have just one imaginary number. They always come in conjugate pairs. So I'm going to write out my function, and then I'm going to start my FOILing. So I'm going to have, with a 0 root, I'm just going to have an x on the outside. I'll have x plus 5. Then I'll have x minus the first one. So x minus 1 plus 2i is going to be x minus 1 minus 2i, square root of 2i. X minus 1 minus 2i, minus 1, minus ends up being a plus. So these are the ones I want to FOIL out first. And you can do that with just using the distributive property, but I like a visual way to keep track of all of my factors. So I'm going to go x minus 1 minus square root of 2i, x minus 1 plus square root of 2i. So x squared minus x radical 2i minus x plus 1 plus square root of 2i plus x square root of 2i minus square root of 2i, and then radical 2 times minus radical 2 is negative 2 times I squared is positive 2. Okay, so I think I've got everything in its right place, and you'll notice we have a negative x radical 2i and a positive x radical 2i, negative radical 2i. So the messy stuff is going to cancel out. So let me go ahead and write what's left over. This 1 and 2 are going to combine. Here's a minus 2x. So I'm going to have x squared minus 2x plus 3. And then I'm going to go ahead and combine these. So I have x squared plus 5x. So I'm almost there. So now I've got a binomial times a trinomial, and I'm going to go ahead and just do it carefully using the box again, because I think if I'm demonstrating to you guys, it's so much more clear. X squared plus 5x, x squared minus 2x plus 3. So there we get x to the 4th minus 2x to the 3rd plus 3x squared plus 5x to the 3rd minus 10x squared plus 15x. So my final answer is x to the 4th minus 2 plus 5 is plus 3x cubed minus 7x squared plus 15x. And that is my final answer. And so does it make sense that we got an x to the 4th? We were only given 3 roots, but because we had to come up with that 4th root, it makes perfect sense that our final answer should be an x to the 4th power, because that is the fundamental theorem of algebra, which is what we're studying in this unit. So we've got 2 more to go, number 53 and 57. So let me get number 53 going here. The directions say we're looking for a 4th degree polynomial. Number 53, we're given a 3rd degree polynomial. So they tell us the degree. They tell us, are they telling us all the zeros? We've got negative 1 and 2 plus radical 5i. And they're telling us solution point f of negative 2 is 42. So let's see what we can do with that. First of all, we can go ahead and add in the 3rd zero. So we really could use the techniques that we did in the last problem to figure this out. Okay, so whenever I have a homework problem and it doesn't look like something we did in class, or it doesn't look like something from the notes, which I don't remember doing one of these in the notes, I always just flip back through the chapter and I try to find an example that's similar. And so that's what I did, and I looked back and I found on page 137, example 5 is exactly like this problem, finding a polynomial with given zeros. So even though we know another technique that we could use to find this polynomial, they're going to have us, instead of doing all those long FOIL problems, they're going to have us multiply together the 2 imaginary zeros, or the 2 imaginary factors. No, they're going to have us multiply all of the factors together, but then there's some extra factor A that we still need to be searching for. So we're going to write it out like this. If negative 1 is a factor, then plus 1. And here we have x minus 2 plus radical 5i, and x plus 2 minus 2 radical 5i. So we still have to FOIL out all this stuff, And then at the very end, we'll use this point that's given to figure out what A is. So I'm going to distribute those negatives first, just so I don't mess it up in my foiling. Oops, and that's not a plus. That should be a minus as well. So I'm distributing out all my negatives. So I get x minus 2 minus radical 5i, x minus 2 plus, and that's not 2 radical 5i, it's just radical 5i. Okay, I think I've found all my little mistakes. So now I'm going to multiply out my imaginaries first. X minus 2 minus radical 5i, x minus 2 plus radical 5i, x squared minus 2x minus x radical 5i minus 2x plus 4, and then plus 2 radical 5i. Here we have a x radical 5i, which I was hoping it would cancel, and there it is. And then minus 2 radical 5i, and that one cancels. So now we just have radical 5 times radical 5, which is 5, I squared, which is negative, and then this negative, so that's plus 5. So all I'm left with is the real coefficients. So we go a times x plus 1 times x squared minus 4x plus 9. And so now I'm going to multiply those out, which, like I said, I could just do the distributive property, but I like this way. X cubed minus 4x squared plus 9x plus x squared minus 4x plus 9. So now we have still our variable a times x cubed minus 3x squared plus 5x plus 9. And we need to use our f of negative 2 equals 42 now. So if I plug in f of negative 2, which is 42, equals, so I'm going to say a times, and I'm plugging in, I keep pointing at something that's not on the screen, I'm plugging in a negative 2 into my function. Negative 2 cubed minus 3 times negative 2 squared plus 5 times negative 2 plus 9. Now I'm working out the math. So that's negative 8. Remember, order of operations, got to do exponents first. So minus 3 times 4 is minus 12, minus 10 plus 9. So this is negative 30 plus 9 is negative 21. So 42 equals negative 21a. Divide it out. And a equals negative 2. So our final answer is, I'm just going to show you that a is negative 2 instead of an a. Back here. So this should be your final answer. Fun times. Okay, and number 57 is the last one, and so let's see what that has for us. So write the polynomial as the product of factors that are irreducible over the rationals, as the product of linear and quadratic factors that are irreducible over the reals, and in completely factored form. So I think we might have found a time when we need to use long division. Okay, so this is where me not having taught the course before, when you guys ask, like, why can't we just always use synthetic? I didn't really have a good answer for you, other than if you ever need to divide something that's an x with a power higher than 1, then you can't use synthetic. So here we are. The hint is that one factor is x squared minus 6. So right there, that tells me if I want to reduce this thing and get it in terms of factors, then I need to divide that out using long division. So x to the 4th minus 2x cubed minus 3x squared plus 12x minus 18. And remember, guys, this is where you actually need a placeholder in your divisor. So there we go. X squared into x fourth is x squared times x squared is x to the 4th minus 0 x cubed minus 6x squared. I'm going to subtract the whole thing. So this is 0. Here we have negative 2 minus 0, negative 2x cubed, negative 3 minus 6, so that's positive 3x squared. Bring down the 12x. So I need a minus 2 right here, minus 2x. So that gives me minus 2x cubed. Minus 2 times 0 is 0. Minus 2 times minus 6 is plus 12x. Okay, so all of this stuff, let me go ahead and show my subtraction. This is turning out, I thought it was going to be weird, but I don't think it will. Okay, so negative 2 minus 2 is 0. 3 minus 0 is 3x squared. 12 minus 12 is 0, and then minus 18. So this isn't weird. This is another binomial that is part of our solution. So right now, my polynomial factors, I've got x squared minus 6 times 3x squared minus 18. And I'm going to go ahead and factor out a 3. So that's 3x squared minus 6. And then when I factored out the 3, I also have another x squared minus 6. So the problem, the directions were kind of worded in a weird way. So the product of factors that are irreducible over the rationals. So that's this one, because we're going to show that the solution to these aren't factorable. 6 is not a perfect square. So when we factor those out, we end up with x plus the square root of 6 and x minus the square root of 6. Now these aren't, and there's 2 of those and 2 of those. These aren't imaginary, but when you have a square root, that is an irrational. So now that's irreducible over the reals. And that is the end of your homework for section 2.5. Thanks for watching.